For this demo, I'm going to try and do as I have done in previous user group meetings. I'm going to try and do something a little bit different. Hopefully you'll find it interesting. The background to this project really is a little bit of maths, a mathematical curiosity. So what I want to do is take this interesting mathematical curiosity and build a little wooden puzzle. And along the way, we're going to explore the drawing tools and how to lay out a multi-part model again, so that we can kind of emphasize some of the better practice and how to achieve some more complicated structured sort of designs. So let's, as usual, I'm going to do slides. Let's just use the software. So I'm going to get straight into the software, and I'm going to create a simple layout at the moment, just 300 mil square. I'm going to work mostly in millimeter units, although I will use sort of imperial tools later on. So at this point, as we've talked about before, this is my design space. So I'm really not worried, apart from giving myself enough space to design the objects I'm interested in, which is going to be about, say, this big. That's all I need to worry about. So I'm just going to accept that. And I'm going to start by drawing an equilateral triangle. And the way I'm going to do that is to use the polygon tool, but setting the number of sides to 3, which is obviously a 3-sided polygon is a triangle. And I'm going to use the side length here. So I'm going to make my equilateral triangle 150 millimeters in each side length. So this brings me to the sort of interesting area in mathematics. So it turns out a long time ago, and I've Wikipedia'd this. So in about 1807, I think. Let me double check that before I tell you a fib. Yes, 1807. An interestingly named group of mathematicians called Wallis, Bolyai, and Gavine, I think, if I pronounced it correctly, they came up with this theory and proved that it was the case that if you take a polygon of any shape and another polygon of equal area to that, there exists, as they put it, a dissection of that shape which will allow you to form the other one. In other words, another way of putting this is that there's a way we can divide up this triangle into a set of common pieces which will be able to form a different shaped polygon. And what we're going to try and do is use it to go from a triangle to a square. Now I've used 150 millimeters here as the side angle. There's no easy way around this, unfortunately. Again, the maths is a bit tricky. You can't, the area of any equilateral triangle that has nice round number side lengths is always a horrible number, unfortunately. And it's just the way that you have to work out the area of a triangle. So unfortunately for us, whenever you put in a whole number like this, you're then going to go through this horrible root 3/4 thing. And you're always going to end up with a slightly horrible area. And of course, we need to get back from that area what the equivalent square would be. So here I've just used the friendly Google calculator to work out the area of my 150 mil side length equilateral triangle, which is this horrible number. And that horrible number produces a probably equivalently horrible number, which would be the side length of the equivalent square. Basically, roughly 98.7, and we're going to not worry about, and we're going to cut this in wood, and the tolerances are going to get a bit crazy anyway. So the important thing here is what that means is if we create a rectangle of that size, 98.7 millimeters and 98.7, and I just create that here. Amazingly enough, this rectangle and this triangle roughly have the same area, pretty precisely actually, within a few decimal places. They don't look it, do they? But they do. And we should be able to divide this triangle in such a way that it would be able to form this perfect square. And the version of this, mathematicians call that a dissection, and the version I'm going to use is one called Dudney's dissection, which is named after another mathematician about 100 years after that theorem was proved. He did a book on mathematical curiosities, and he showed this nice one that goes from an equilateral triangle to a nice square, and so it bears his name, Dudney's dissection. His name was Henry Dudney. Okay, and the way we do that dissection is we're going to make use of our drawing tools. So I'm going to turn on the polyline here, and I'm also going to make sure I've got my smart snapping on. So you've got two types of snapping up here, the geometry and the smart snapping. And to start with, we're going to use the smart and the geometry snapping, but in a minute we will turn that off to make life a bit easier later on. So what I've done here is, as I'm dragging down this line, I find the halfway point down that angle, and as I start to draw a line, I can get it to be vertical until it intersects the base, like so. Now, with the polyline tool, it will continue to draw a polyline, but if I press the space bar, I can draw a fresh polyline without having to exit and reopen the tool, which is, when you're drawing lots of separate polylines, that's really handy to know. If you press return, you complete the polyline and exit the tool, but if you use space bar, you can stay in the tool. Okay, so I find the equivalent on the other side, look, the halfway point, and then just drop that down vertically till I find the intersection with the base. And now I'm going to draw a line which connects this point to this point, so that halfway point to the baseline that the base intersection we just found. And that's going to be one of our cut lines. The next cut line is going to be difficult to find, because what I want to do is find the line that runs from here, but it intersects this line at exactly 90 degrees. Now that actually turns out to be a little bit difficult to do. We can sort of do it in reverse though. So what I'm going to do is I start to draw anywhere on this line, and our smart snapping gives us the 90 degrees there. So you can see that we can pick up 90 degrees from this. Let's do that again. We can pick up the 90 degree point from this center point like so. Okay, so as I've come out, I'm just drawing a line that is 90 degrees off here, but obviously it's not going to connect up with that. So what I do instead is I can just drop that back on to the end point there. So now what I've got is this line, and if we were to continue it out, it will intersect that line at 90 degrees. Slightly awkward way of doing it, but that's the best we can do at the moment with our smart snapping. I'm going to take another copy of that, so I've just dragged it. I'm going to hold down the control key as I snap that endpoint onto the other side, so that we now have these two lines. So just to be clear again, so it's this line is coming down, but this is a line that we created to know that it's exactly 90 degrees relative to this main line. And that's going to be important because obviously we need to generate corners of this square. So I'm going to pick that line, and I'm going to use our extend, which just simply takes any line and it will extend it to an intersection in the geometry. And again, I can pick this line and just choose the other line here, and it will extend that so that they intersect precisely. And really that, if I now remove this line and this line, these are the segments that Henry Dudney defined that will reorientate to form exactly a square of this area. Well, let's reassure ourselves that that is true. So what I'm firstly going to do is create a new layer so that we can start to work afresh on a new layer. So I'm going to call this layer that we originally had now construction, because ultimately it's just for our guidance. And I'm going to create a new layer, which I'm going to color orange, so hopefully you can see it in the demo, which we're going to call just parts for now. And this, what we actually want to do now is trace out these parts. Now, there's various ways that you could take the artwork as it stands now, which remember is just a series of unconnected lines, so they're not closed shapes. To create this, we can do this various ways, but honestly, I feel like the simplest way in practice is that you just draw it, right? So I make sure my parts layer is the active layer here, and I'm going to just trace around very carefully, trace around these things. Now, while I'm doing this, I don't want all that smart snapping going on, because actually that's going to distract me a little bit from the task in hand. So I'm going to turn that off for now so that I just get fewer distractions. In fact, I think I can turn both off, can I? Now I need to have that one on because I want to get the nodes here. So this one, and I'm just picking up the node selection here so that we make our way around to produce this shape. And as you can see, I've got my nice orange over the top. Hopefully you can see that on the video. So same again, just making sure that I do get the snap points right. So that's part 2. Third part, it doesn't matter which sequence that I'm using here, just making sure that as I click that the snap indicators to me are showing me that I am finding the geometry that I need. So the white square is a node, which is fine. That's an intersection of the two lines. And again here, and then back to the beginning. Okay, so that's created now the 3 independent parts that I need. And let's take a copy of those and see if we have in fact created what we think we should, right? So actually at this point, what I can do is I can lock that construction layer so that it won't cause me any trouble. Take a copy of these pieces, just drag them across the side for now so that I can rearrange them. Okay, so what we're going to see here is if I take this part here and we're going to just rotate it. So the equivalent of rotating it is to mirror it horizontally and vertically. And I can take that bottom node there and just find the equivalent on that side. Similarly, this part I'm going to rotate it, which is equivalent of horizontal, vertical mirroring. So I'm just pressing H to horizontally mirror something, and then V on the keyboard. And then this part we can just drop at the top here. And you can see now that we've recreated this rectangle. And in fact, if we take, I've locked that layer now, so I can't take a copy of it. Let's unlock that. If we take this rectangle and we kind of drop it in there and change the rotation center to be that corner. So if I click the middle, I get the rotation center, rotation center, click that, rotation center, he said, and drag it up to the top corner. Now that we can rotate around that point, and you should see that we have got within our tolerance a rectangle, or a square now that will be 98.7 millimeters square. So that looks plausible, right? So what we've got there is a set of component parts that if we cut them out can be rearranged to either form an equilateral triangle or a rectangle. And that's going to be the basis of my puzzle. But there's an even cooler thing about Dudley's dissection, which is it's a class of dissection which is also called a hinged dissection. And what that means is actually there are points of contact that can be maintained all the way through the transformation from the triangle to the rectangle. And the easiest way I can show you that is with a little animation here, which shows you our triangle becoming our square. And as you can see, actually there's a hinge point here and here and here. So just 3 hinge points, they maintain contact throughout the whole transformation. And now you can see why there was a sort of rotation of this part to get it into place. Okay, so this is pretty cool because it means that we can actually build a single object which stays coherently connected as you transform it from one shape to the other. So that's my plan next. And the way I'm going to do that is going to basically drop in some hinges. So we'll go back to my design here. Let's drop those out of the way for now. So where were the hinges again? Let's pop those in, and we're going to make them. Let's just do some little 6 mil. I need them to be pivot points that are going to be strong enough in the wood. I've chosen 6 mil just to be a reasonable kind of size. So there's going to be a pivot point there, a pivot point here, and a pivot point here. Not one here actually, because that's the split if you imagine. And so these are going to be the places around which, if we just go back to that, you can see again. So one here, and one here. All right. Okay, so that's the idea. And we're going to start thinking about the manufacturing space now. So around these hinges, I think the key here is we're going to make a kind of dowel and a socket for them to go in. And the socket will be will need to be able to machine around that. If I use, I'm starting already to think with my design that the design has to take into account some realities of manufacturing. I'm going to use a 1/8 end mill to cut this out of the wood. So that really means that I don't want anything smaller than 3 and a bit millimeters, so that that tool will be able to get in. So what I'm going to do is add an additional radius around here, which is just 4 millimeters off here. So in total that will be 13. So that's given me a 4 millimeter gap between the inner and outer of our hinges. And really that is the geometry that I'm going to use to make this part. At this point I have been pretty lax with layers, so everything's sort of sitting on that construction layer and another one called parts. Okay, so again I'm just going to lock this one so it doesn't cause me any trouble. But now I want to think about how I'm going to manufacture this. So I'm going to cut these parts out of a piece of scrap wood, nice wood though. I've got a nice bit of door frame that's oak, so I'm going to use an oak panel. I'm going to halve this first, so that's about 420 mil in half, and this is about 150 mil, and the whole thing is 20 mil thick. So that's what we're going to use. And so now I can start to think about the manufacturing space. I'm going to go to sheets and make use of the new sheets functionality. So first thing I'm going to do is just rename this one to be design, because that's all it's going to be. Just a place where we can lay out design ideas. And the new sheet I want to add is going to be that piece of oak. So it's going to be a piece of oak. I might as well put the thickness in there just in case I need to refer to that more conveniently. And the dimensions of it actually, as I mentioned, by the time I've sawn that in half, it's going to be 420 and 150. And 20 mil thick. We are going to use the material surface. The datum can be bottom left corner. It's quite convenient for machining. Resolution's not issue. I'm not going to do any modeling on it at this point, but I will set it to be an oak color, just so that the visuals kind of line up. Okay, so this is where we're actually going to lay out the manufactured parts now. So the first thing we're going to do is sort of create those parts from the original design. So if we go back to the design space here, I'm going to take each of these parts in turn. So this one, and this one, and I'm going to make copies on the oak. Okay, and it comes across in the same physical location on the oak. So what we might be considered here is we'll just drop this sort of down into the space. So that's that one. Back here, so I'm double clicking to swap back to my design sheet. I want this and this and this and this copied across. And again, we're going to just position that so that we're separating the sort of pieces out roughly. I'm going to sort out the nesting at the end. So remember, this is one with a peg. This is one with two. This is going to be sort of the male part, if you like, female part, male part again. So this one is going to require that and that and that and that and that. So let's copy that across. So that's this part. Already I've caused myself a bit of an overlap there. Let's separate those out. So you can see without really mucking around with my design, I'm keeping everything quite neat. And the final piece then is going to be this part with this joint here. Copy that across, and that's the kind of final piece. Again, I've managed to get myself a bit tangled up there. But hopefully you can see that it's still kind of very nicely organized way of thinking about stuff. So take that, just drop that out over here. So again, everything's sitting on the one layer at the moment, but now I'm going to think about the layers as opposed to the sheets. So these are the parts for sure, but what toolpath strategies are we going to apply to make these parts? And that's when I kind of start to think about layers again. So I'm going to add in the layers that will define which art relates to which part of the process. Okay, so we're definitely going to cut stuff out. And let's just, in our minds now, let's just have a think about what we're going to do. So my plan here is that the parts here, some of them will have a peg at that joint, which is the sort of 6mm peg like that. Okay, and some of the parts will be the other way around. Okay, so they're going to have, if you like, that piece and that piece. This is their main bit, and they're going to have a matching drill hole through which that peg will insert inside. Okay, so these parts, which I'm going to call the female parts, okay, they are actually going to be cut from the wrong side. If you think about it, we need to cut them from this side, and that means we're going to need to flip the parts, otherwise we're going to end up with mirror images by accident. Okay, so the first thing I want to do is decide which of my pieces here are the female parts. So as I said, I'm going to go male, female, male, female, which means the two edge pieces, these two lower corner pieces, this one, yep, and this one are in fact going to be the female thing. So the first thing I'm going to do is I'm going to flip those. So I'm just using the keyboard H to flip them over so that they are mirror images, because we're going to cut them from the other side. Having done that, I think we can kind of relax. Then let's think about the toolpaths. So this part now is going to actually be this way up. And we're going to cut down here. We want to sort of pocket out all this area above the hinge on this one, and we want to pocket out the area either side of the pins to make the hinge on the other side. So I'm going to create a layer called pockets as well. And then finally, we're going to want to come back in and cut this hole out. So effectively, we're also going to want a layer called holes, where we'll come back in and just take out those holes. Right, so now let's start sorting out our artwork onto the right layers. So remember, everything's currently on this layer called parts, but we're going to use that to sort of start to move things across. So these are the female ones. So we know for starters that they're the only ones with the holes in. So let's do the easy stuff first. That needs to go, and let's copy them across. Copy them to layer holes. Okay, and we can make that sort of red so we can see it again. It's slightly different. So that's the bit we're going to drill out. The bits that we're going to want to pocket is essentially, for the male parts, is going to be between the edge and the pin. So between the edge and the pin, and the edge and the pin. But for the female parts, it's going to be the whole bit above the hole that we're going to want to pocket. Okay, so those are the things we're going to want to pocket. So I'm going to copy those across to pockets, and we'll give that a little different color as well, just so we can see it more easily. And then that leaves us then with the cutout. Now the cutout is basically going to be these main shapes and that edge shape for each of these parts, right? That's what we're actually going to cut out. And ultimately, we are going to want those to be kind of welded. So I'm going to copy those to the cutout. Okay, and let's make that a different color again, so maybe a blue. Okay, now we should be able to turn this off and start to see what parts we've got here. So we've got a cutout path, which is just the external shapes. So again, if we select that cutout, go into the drawing now, I can just select all those and say, let's just give me the external outline of those. That's actually the cutout path we're going to want. We will come back and have a little chat about filleting in a minute. I mustn't forget that, because there is a filleting issue a little bit, depending on our tool geometry in a second when we come to machine it. But let's go back to the layers. So that's the cutout. That looks pretty good. Pockets seem pretty straightforward, so that's what we're going to just come down and pocket in between. And then there's the holes, which are just literally the drill holes. Okay, so these are all the parts now that we want to cut. Let's get rid of my drawing at the top. Don't need that anymore. So remember, what we're looking at now is three different layers of artwork all together. But we want to nest all these things as groups, but we know that the artwork is all lying on the right layer for machining. So for now, what I'm going to do is I'm going to group all these objects as parts. So I'm just going to press G on the keyboard and just start to group them. So at this point, we've kind of lost they're all ending up on the layer that's just active at the point where I group them, which isn't isn't ideal. And you might think I've lost everything, but we'll recover it in a second. I'm just going to nest the parts now. Using the nesting tool. So we can select, all these parts we're going to nest. Just one of them. We can remove the original parts because these parts are all simply for the purposes of manufacturing now. So we're just going to let the nesting tool have at it, if you like. The tool diameter, well, the tool diameter is actually going to be 3.12. We know it's going to be a bit bigger. We probably leave a little bit of a border gap there and a bit of clearance. So the border gap is around the edge and the clearance is a little bit extra over and above the tool diameter. We can rotate the parts though, and we can just stick them in there. So we're going to ask it to pack them down nicely, which it's done, and I'm happy with that. Now remember, these are all grouped, and that helps the nesting system know what was what. It would have probably worked fine without grouping them in this case, but it's kind of a nice habit, and you shouldn't be fearful about grouping parts, because the crucial thing ultimately is when you come to ungroup them, just remember to ungroup them back to their original object layers. Okay, and when you do that, they will revert back to the layers that we set up. Okay, and this is obviously a choice that you can make, but in this case, because the layers matter to us for the machining that's about to come, then I can ungroup them back. So I've done the nesting and I've ungrouped everything back to its layer again, and it means all the holes are in the right places, etc. All right, so let's come across and do our tool pathing now. So I'm going to pin this out because I'm going to be in there for a bit. I'm a great fan, because I've set everything up on layers, I'm a great fan of associating my toolpaths with the layers. So let's start with the pocketing. Okay, so if I select the pocketing toolpath, I've got my 1/8 end mill. And again, I've got it selected. My tool database includes hardwood, so I can select the hardwood and have the feeds and speeds be appropriate and stored for a kind of oak or independently of, say, other material types. Now, instead of the cut depth, though, what I'm going to say here is I'm going to cut down for these pockets to half the material depth, whatever that is, which is Z/2. And I can just leave that in equation form. And it means if at a later date we were to change the material thickness, we would still always allow our hinge and socket joints to be half the thickness of the material in each case. As I said before, I'm quite keen on using this, so I'm going to associate with the toolpath. I'm going to use the closed vectors that we know are the thing called pockets. Nice and easy for me to remember, the pocketing toolpath. I think that's it. I'm just going to calculate that and take a look at what we get. So we get some pockets and some pins, which seems plausible. That's what we're intending. I would probably at this point as well start to think about, we are going to think about some allowance on here. So I would almost certainly feel like we probably got to allow the pins to be a little bit smaller. What tolerance you use is a little bit of the black art. I've tended to use about 1/10 of a millimeter, which just guarantees it's going to fit in there, but probably you can get away with something a little bit looser than that. And I want it to be an overcut, really, so I'm going to put minus in there. So we're going to overcut the parts slightly, and we can, the best way to see those usually is to come back into the 2D view and to turn on your solid 2D preview. That gives you a much better view, I think, of what you're overcutting. It's very hard to see anything relating to this in the 3D view. So you can see here, that's what I'm making my pockets slightly bigger so that the hinge regions around here will be just slightly overcut, and the pins, because they're overcutting inwards, if you like, the pins will be slightly smaller than 6mm, and hopefully that will give me a nice fit. So that looks good. Okay, so that's the pocketing. I am going to close that down. We're going to just put in the drill holes now, but I'm not really going to drill them. What I'm going to do is I'm going to profile them out with the tool, but I am going to assume that because we've pocketed away the top, that we can in fact use the start depth, which is where we left off the pocketing, Z/2, and the cut depth therefore will be in fact Z/2 as well. Okay, I'm using the same tool. We've got various passes here, but actually if I add in a zigzag, you know, we can probably just zigzag it down into the base here. So again, this is all a little bit about what you feel you want to do, but I'm going to sort of zigzag this thing in and just try and cut it down in one go. I am going to use the toolpath association, close vectors that we know are called holes, and we can see here that seems right. Close that down. So this is now automatic, and I'm just going to call this holes. Calculate that. So this looks, does that look plausible? So if we turn off the pockets, we should see that we're actually plunging into the base of those holes and just ramping down and cutting them out. So hopefully that will be quite efficient. Let's just preview that to see it happen. Okay, that didn't look right. So what have I done wrong there? Not at all what I was expecting. They have, for some reason, gone outside the holes instead of inside because I had outside on. What an idiot. Okay, obviously we want to be inside the holes. Now, one of the nice things is I can just click recalculate because all the selection is taken care of. Hooray for simulation. What an idiot. Right, so when I'm using profiling to do drilling, of course, or hole cutting like that, really, I need it to come inside. Now you can see I'm back to my 4 passes, which is not a, so we'll drop that down. We don't need it to do 4 passes and retracts. So I'm gonna risk just getting in there. Set the passes at 1. Okay, calculate. Let's make sure that looks pucker. Right, that does look pucker. Now, obviously, because of the spiraling in here, you can see that we kind of get away with the fact that we're really cutting down this hole and clearing our way in. So hopefully that's good. Put the pockets back on. Let's reset the preview and just preview both the pockets, and the holes. That's what I was expecting to see. Some upstands, some sockets. Right, perfect. Okay, so the final stage then is the cutout pass. Now this one, again, now we do need to remember, this time profiling, same settings all the way through, so down to Z. We do want to cut, not pocket, what we're doing here, profiling. Down in Z, we do want to go outside this time. We probably want to add some tabs, just a couple of tabs to make sure, depending on your hold down mechanism, we don't need tabs here. We don't need that many tabs. Let's edit the, let's close that down because what I actually need to do is get the selector working first. So I'm going to close vector, associate with toolpath, and we're going to use the cutouts layer, not the holes layer. Okay, now we can put the tabs in sensibly. Okay, so the tabs look pretty good. What happened before, just for clarity there, is that I went into the tabs before we'd really made the selection correctly for the vectors. So I just sorted that out. We'll probably ramp that in as well, but smoothly. and this will call cutout to separate it from the pocketing and the other toolpath calculations, and that's us. It's just going to do a lot of passes here, but it's a hardwood. So again, depending on your tool database setup, you might find you want to do something different. So there are the parts. They all look plausible. So these two, remember, we're going to flip those over to attach to our male parts, which is why we had to flip the artwork to begin with, because ultimately that part will be taken out and then turned over to place on top of the other one. And we are good to go. So the only final step for me now is to save this toolpath out. And what I'm going to do is actually save that they've all got the same tool. So what I just want to do is make sure that the ordering is sensible, right? So I know that I have to pocket first because my hole drilling assumes a pocket above those holes. Then I'm going to do the holes, and then I'm going to finish with a cutout at the end. So that's the right sequence. I've got the visible or toolpath in one file, so I can simply save the toolpath out now. It'll be one toolpath to do the lot. And you can see here that I've already saved a similar one. And we'll take a look at the machining next. But that's the basics of laying out the part for the first stage. So now we've seen the design process, we can just use the power of the internet to skip forward 45 minutes and see the end results of the machining. So basically it was set up pretty much as you saw. And the nice thing about the sheets is it all kind of matches what you'd expect. So there's the oak taking the little pocketing. You've already got an example of one of the pegs, and this is also dropping in one of the basic pockets onto which the other stuff will go. And the result really is that we took our piece of oak, we're able to cut our pegs and our pockets ready for the cutout pass and the final hole drilling for the hinges. The eagle-eyed amongst you are going to know that although I said we're going to have to come back and think about the little filleting issue on this profile, I didn't do it, did I? So you can see here there's a little tiny fillet on the edges of those hinges, and that just makes the fit as you adjust and bring the corners of the parts into those gaps. They do not go quite nicely, so that's a bit of a shame. And unfortunately, it means even though this is pretty much filmed straight off the bed of the machine, as you can see, everything fits together. The fit of the joints is fine, but it's a little bit springy, and that springiness, which is preventing them all coming together nicely, is to do with the little fillets in the corners of each of those hinges. So what do I kind of mean by that? Well, really what I'm saying is that here, when we did the cutout pass, what I didn't do was allow a little bit of overcut to clear this sharp corner. And that means that you're pressing the shapes into a space which has got this little filleted radius in there, 1/8 rad. What can we do about that? Well, to be honest, they're a little bit awkward to fix. What we can do, if I just turn off the 2D preview here, and the toolpaths, we can drop in something manually. The sort of fillet we need, obviously, is not just to take out the sharp corner, but is to overcut, allow the tool to overcut so that it can actually meet the sharp corner, which is a dog bone fillet. Sadly for us, because of the nature of this one, which is this line segment into an arc, our dog bone filleting simply can't do it as an automatic process. So instead, our only option really is to drop in some little rads ourselves. So our tool, if you remember, is 1/8, which is 3.125 millimeters, and I can drop one in this corner, and we're going to need one down the bottom corner here. So if I just take this in by eye, really, I can snap it in there and see that that's where the tool needs to come in to capture that corner. And similarly, if I grab this one and just move that into place and snap it in, you can see that that's what's going to be required. I'm going to need to do this for every one, and really the only way to do this is to then chop that shape out using the subtract in our Boolean sort of operations here. So it's a little bit laborious, and the end result is a little bit of an overcut, you know. So you could do that by choice if you wanted to. It's what I intended to do, but forgot. And so the end result was that I had to just, fettle those corners myself with a box cutter. And actually, it turned out took about a minute, 2 minutes, and probably you get a neater job. So I just got chiseled out effectively those little rads manually as a post-production process. For a one-off job like this, that's the lesser of evils, I suspect, and it probably slightly more sightly final result if you want to do it that way. But this is how you would go about filleting it if you needed to. And if you were mass producing and you want to minimize your finishing, then that's probably what you'd do. But there you go. So that's just taking a mathematical design all the way through to finishing that puzzle. And as you see, it comes off the machine because we've taken into account the tolerances and things in the process of creating those toolpaths. It comes off the machine and pretty much slots together. If I hadn't forgotten the filleting, happy days. But as it turned out, as I said, it wasn't too bad to finish by hand. So what we've seen up until now is all essentially 2D work, really. So it's just been pocketing and cutouts and stuff like that. So everything we've seen here could be done in Cut 2D and above. What I'd like to do is kind of take that design now and maybe go on to the next level. And I want to use sheets in a slightly different way than the way we've seen it up until now. So we've been using sheets up until now to represent different material types. But I also want to show that there's this other important aspect of sheets, which is to allow you to show different ways of laying up your job as well within the one file. So let's cut back to where we were on the project. So we've got our 2D stuff up here. Let's go back to the layers and turn on the parts and go back to our design space. Okay, and I'm going to get rid of that version of our design. So what the plan is now is what I'd like to do is create a jig into which both orientations of our puzzle will sit. So we've cut the puzzle out of a piece of oak. Now I want to cut independently out of a separate piece of material a jig which matches that puzzle in both its configurations. We can drop the puzzle into that jig and then remachine the surface of the puzzle in its two different orientations. And that's the key really, because what I'd like to do is do two different pictures in the two different orientations so that when you change the puzzle's shape, you also change the picture on the surface. Okay. Hopefully that sounds interesting, right? What I'm about to show you should all be effective in VCarve Pro and above. So as long as you're using clip art, from D&M, or provided by us, then VCarve Pro is perfectly adequate for that. If you want to do your own custom artwork, obviously your own custom 3D shapes and stuff, then you'd need Aspire. Right, let's start with the jig. Let's make the jig first. That's fairly straightforward. But what I want to do is also think about which areas in the shape, in its two orientations, we'll be able to put our surface decoration. And to do that, I'm just going to rerun the thing that we did earlier, broadly speaking, but with a new bit of geometry in, which is an area, a circle, which represents the center of the shape when it's in its triangle form. Okay, and then what I'm going to do is retake copies of the original puzzle, just as we did before. So I'm going to take the top piece and the circle. I'm pressing Control as I drag these out so that I get copies of the parts. I should also make sure which layer am I on. Cutout, I don't want to do that. Let's go back onto the parts layer. Okay, because in a minute I'm going to be making more parts. Right, that one and the circle, let's drag that out. And this one and the circle and drag that out. And the final corner with the circle and drag that out. Okay, now I want to get rid of the circle that's not inside the shape. So I'll just use the old scissors, which are a really nice feature. And now we can see we've got our three parts, but we've also inscribed on them the area that forms the center when it's in the triangle form. Okay, hopefully this is all going to get clearer in a second. Let's just flip over these ones. So I'm just going to go horizontal and vertical, because remember, these are kind of, to get to the other orientation, these parts rotate, H and V. And then let's just snap the whole thing back together again in the square form. So let's pop this down here and move this part into there. Good. And grab this one and move that across too. And then this one. Now what you should see, rather pleasingly, is that the area that was the center of the triangle, i.e. this bit and this bit and this bit, this bit, now are the edge of the square. And that gives us a whole fresh piece that was formerly the edge of the triangle into which we can drop some new artwork. So that's quite good, and it looks like the idea might just work. What I should have done at the beginning is also kept the hinges here, so let's do that as well. So I need a hinge shape, so press Shift and multi-select. As I drag it off, there's a hinge either side of that one, and one down here. Okay, so those are the hinges when we're in the square shape as well. Right, so that's the two layouts that I'm going to use as the basis of both my jig and my carved artwork. So I should just move that circle onto the right layer. So let's just move that two parts from cutout because it shouldn't be there. Right, let's create a new sheet. So the first thing we're going to do is I'm going to create the sheet which now represents the jig. I have a piece of MDF for that, just cheap MDF scrap. It's 300, roughly 300 mil square. It doesn't really matter how big it is, but what does matter when we create the jig is where we put the origin, right? So what I'm going to do is when I create this piece of material, which we're going to call MDF jigs, I am going to make sure that the origin, I've got caps lock on, that would explain that, of this part is not on the edge of the part. It's going to be on some piece of the design space that we will be able to locate subsequently, right? So what I'm going to do is, and this again, hopefully this will become clear in a second. Let's just edit this. It's 300 mil square, as we said. That's right. That's about right. It doesn't actually even need to be that big. It's going to probably be only 200 mil across, but 300 high is good. And it's 12 mil MDF that I have to use for this. Might as well set the color again just to stop any confusion later on. So we've got MDF in our list here, so let's choose that. But here's the important thing, right? I'm going to set the datum position to be in from the bottom left corner here by -15 and -15 millimeters. So it's just going to come in 1.5 centimeters from the bottom corner. That's where we're actually going to set 0, 0 in XY for our tool. Hopefully you'll see in a second why that makes some sense. Go back to our design space here, grab this one and this one. And we're just going to make copies of these two designs. We're going to copy them across to our MDF jig sheet here. And now what I'm going to do when back on this jig sheet is I'm going to take this design, this whole design, and I'm going to drop it down so that that corner sits at 0, 0 here. Okay. And we can do that by going to, well, two ways of doing this really. We can either just move it down there by we can take it down there by moving it by exact amounts, or actually often a simple way of doing this is simply to create a 50 mil square at the bottom corner here. There at 0, 0. Yeah. Create that. Oh, didn't mean to do that. I meant to do that. And then we can just snap all of that against that square. That's quite a nice way of doing it as well. Okay, so that now means that when we come to do this, we can put the tool in the corner of the triangle, and we know that that's going to be 0, 0 for the purposes of all the subsequent toolpaths that are based on this jig. All right. The other thing we need to do is not forget this time round, like I did previously, to fillet the corners of this shape, because this shape is going to be a cutout ultimately. And so we mustn't forget, and I'm saying it again too early because I probably will forget, but we need to fillet these corners when we come to cut this shape out. Okay, the other one doesn't matter really where this one goes, because we know that when we set the origin here, we'll be able to find the toolpath in that space too. Right, let's just create the cutouts. It should be very straightforward. I'm going to do it the easy way to find the boundary of something again is kind of just as easy to sketch it pretty quickly, I find. So let's find that boundary. What we should do though is start to create a new layer. So I'm going to move these to a new layer, move to a layer, new layer, which we're going to call jig. Okay, we probably should make that the active layer as well. Similarly now I can sketch out the triangle again. Like I said, there's various ways you could do this, but I find that's just as easy as anything. And then we're going to copy across these outer circles into that new layer as well. So we're going to copy those to the jig cut layer. And now here we can just turn off everything apart from that layer, and it should look plausible, which it does. And then I can pick up each of the, let's just group select those, and we can just knock out all of that. So that's now basically, including the hinges, that is the shadow
of our parts. But as I said, mustn't forget to fillet these corners too. So we're going to use a dog bone fillet. I've got a 1/8 ball nose, which is 3.125 millimeters, but over 2 because it's the rad we need. So that equals 156, etc. And let's just bung those fillets in here. So just so I'll zoom in so you can see exactly what I'm doing. So this is just allowing the tool to get right in there so that the sharp corners of our part will still drop into that shape neatly. And then one final thing we might consider, just for the ease of getting the part out again afterwards, is just to drop sort of a finger access here to each of the parts as well. I'm just adding a reasonably big circle diameter here so that we can access the edge there to lift the part. Typically, the lateral movement on these parts is going to be stopped by the jig itself, which will be clamped down. But if we cut right through the jig, we probably might use some sort of hold down as well, just to stop the parts lifting. There shouldn't be much lift involved in this job, but just in case they did, I sometimes put some double-sided sticky tape on there, and then you sometimes want a place where you can get a bit of leverage underneath it. So I'm just giving myself a little bit of an easement access point there. That's it. As you know, I quite like to come in and use the fact that we've put everything on the layer. So what we can do here is just use our profile toolpath. I can use the selector to say select everything associated with the toolpath that's on the jig cut layer. So that finds the vectors as we would expect. We can use the 1/8 end mill. We'll set it to be Z thickness of the material. We're going to cut inside these vectors. We might want to do several passes. We probably want to add a ramp in if we're cutting into it. But essentially, this is going to be called the jig cuts. Okay, and that's it. And we should see in our MDF, we can drop this piece on, find our kind of rough area 1.5 centimeters in from the edge, and then we're just really going to cut out these parts to make on the bed of our machine now a jig into which we can place our previous puzzle in its 2 different layouts. So that's that part done. Okay, and we'll be able to stick that on the machine and cut it very trivially. Now that we've cut that, we want to now assume, let's imagine we've put our piece into this. What does that toolpath look like? Well, really, we need another sheet again. And this time, we can use all the same settings really as the MDF jig sheets. Okay, but I'm going to, this time it's back to 20 mil and it's oak again, because obviously what we've got here is the actual oak parts that we made before, and we're going to rename this as puzzle jig. Okay, so this is the puzzle in the jig. Let's turn our layers back on and nick back those parts that we saw we had laid out previously. So across here I can just take a copy of these and say copy them to the puzzle in jig sheet, and we've got all of our parts back here for making our puzzle. Of course, we're only interested for now really in identifying the center area here, because all I need to do now is drop a 3D piece of clip art into that area and generate the toolpaths for each one of those bits of clip art, and everything else should then work out. We'll be able to find the XY coordinate by using the bottom corner of the triangle. We're going to set Z off the top surface of the oak puzzle in situ once it's in the jig, and then we're simply going to machine over the surface to carve away a little pattern in each. So let's choose what we're going to do. Now, for the purposes of this demo, I'm going to use one of the pieces of clip art that we already have in our demo library, which is this Sleepy Mouse, and I'm using the C version, which is the chiseled version. And the reason for that is because it minimizes really the amount of data that we're going to have to, the amount of wood we're going to have to carve away, and it fits, as you'll see, quite nicely into approximately the shape that we have available to us here. We can even just rotate him a little bit. So I don't think we have to be super exact, because obviously there's going to be some give here, but wherever he's creeping over the circle here, we can see that he's creeping inside this space. So there might be a little bit of, depending on your artwork, you're going to have a little bit of playing around with this to find the right match. Okay, but that's one of them. The other piece of clip art is from the D&M site. It's in the same style, and so we've included this particular piece in the UGM resources pack. If you bought the UGM pack, you'll have this piece of clip art. Obviously, I'm just using these as demonstration. You can use any design you like, and if you're an Aspire customer, you can create your own designs to go into these spaces. So let's go back to modeling and use the conventional import this time. And on your pack, you should find this this clip art piece from the D&M site, and hopefully you can see it's thematically consistent and looks like the cat has got on his mind that mouse. And so what we're going to do now is just carve these, but we're going to carve them independently. So I'm just going to turn off, we'll have a cat first, into the toolpaths. Okay, just close that down for a second. And I'm just simply going to use the straightforward machining. I've got a 1/8 tapered ball nose, which is what I'm using for this. Both the models at this scale are quite, they're not very intricate, so you can get away with a 1/8 rather than a 16th. We're going to use the model boundary, just going to basically machine it, and we're going to call that cat brackets triangle. And you can see, we're playing that one back, that we'll carve the cat in when it's in situ in that position. And then we can just swap over the 2 bits of clip art. Go back to our toolpath here, let's just pin that out. And then just because I'm lazy, we can duplicate that one and open it up, and it'll have all the same settings. And this time we can call it mouse square. And that should be it. Finds the model, finds the boundary, and we can now cut that one independently. Notice that they both are located against that common origin, which we know when we've got the jig laid out is the bottom left corner of the triangle when it's in that form. So as long as you set XY there with your tip of your ball nose, then you set the Z off the surface of your puzzle, you can carve it if you like. All of this now, of course, is stored in one file, so that's kind of handy. You've got everything from the design space all the way through. We can recut as many of these parts as we like. Presumably we only cut one jig, but we might cut several puzzle faces. Now we can store them all together in the one file, which captures all of that, those sort of permutations of the related aspects of the same file. Anyway, I hope all that was interesting. I hope you all understood that last phase. It's, like I said, a bit of a stretch goal, but certainly I think there's lots of potential. As always, I would really love to see what people do with this idea if you decide to give it a go yourself. Okay, great. Thanks for listening.